Hello, everyone. Welcome to Gateway API Table Stakes. Today we want to talk to you about Gateway API in terms of recent highlights, finishing touches, what table stakes means for Gateway API, the future of Gateway API, and we bring to you today.
Hey, so yeah, I'm Lior Lieberman. I do gateway stuff at Google. And yeah, recently we launched as well agentic networking, which is something interesting I'm going to talk about as well.
I'm Candace Holman. I work at Red Hat, and I'm also working in the Gateway API Special Interest Group.
And I'm Mike Morris. I work at Microsoft. I'm a product manager. I was one of the folks that helped start the Gateway API for Mesh initiative. And yeah, I've been working on Gateway API for about 4 years now.
And I'm Kellen Swain. I'm with Google. I'm a maintainer of the Gateway Inference extension.
And I'm Shay Nutt. I'm an SPSC at Red Hat, a SIG network chair, and a maintainer of Gateway API. So we're going to do a brief overview of Gateway API. How many people in here are new to Gateway API? Show of hands. That's a fair amount. How many people are using Gateway API in production? How many people are using Gateway API in anger? At least a couple. If you realize the answer to that is yes, during the talk, a big part of what we want to do today is be available for Q&A. So think of your questions and be ready for them. We really do need the constructive criticisms as well as the any other comments and questions that you have. So we'll do only a brief history. Gateway API started in 2019 and was intended to be the next generation of Kubernetes routing and load balancing APIs. So the successor to ingress. We also had aspirations of kind of being like the follow-up or the next generation of service. That's been a little bit of a different story, but we are basically the effective successor to ingress, as no new features are going there. All new features are going to Gateway API. We went V1 GA in 2023, and we have 30 plus implementations. For those who are new to Gateway API, one of the things that is often a source of some confusion is like you join and you're like, all right, Gateway API, I want to do stuff. You really have to start with an implementation. We do not provide a default implementation. So we have a link here to our implementations page, and there's a lot of them. And that page we know is a little bit hard to navigate. So we're actually working on improvements to that. So just a heads up on that. If you get confused, hit us up in Slack, talk to us about like what you're looking for, that kind of thing. But being GA in that doesn't mean that we're done. As a matter of fact, we call this talk table stakes because we think that there's more to it basically to have table stakes in the sense that we are at the point where we're pretty much generally good for most implementations. And that's what we're going to talk about today. But going back to what Gateway API is, just for those who are new, brief overview, it's a role-based or a role-oriented API as opposed to like ingress, which was just like, there was just ingress. So our roles are like the infrastructure providers, the cluster operators, application developers, and our APIs try to align with roles quite a bit. It's designed to be expressive and extensible, so there are extension points and stuff like that to be able to add your own CRDs or your own policies or your own filters, etc. Ideally, you extend it without annotations, and that's been a constant thing that like has been one of the driving forces behind extensibility in Gateway API is trying to avoid the previous generation of like annotations for everything. A basic example, so this is kind of just like if you're really new, the most basic example is where you would have had an ingress resource before. HTTP route is pretty much your closest parallel. But you don't just have the HTTP route. The HTTP route actually needs to be attached to a gateway, and the gateway class needs to, or the gateway needs to attach to a gateway class. So there's a little bit more complexity in here, but it allows you to have those role boundaries and have different APIs for different roles. Gateway class is a little similar to ingress class if you're familiar. So you can see here that we have like an HTTP route. It might feel familiar to an ingress resource where you have rules and you match patterns. In this one, you match a path and you go to specific background or backend refs. So this is like a backend service. We have a bunch of available APIs, including the ones I just showed you. So gateway class, gateway HTTP route. We also have gRPC route, reference grant, gRPC route might be pretty straightforward. Reference grant is for allowing references between namespaces. And backend TLS policy, which we'll talk more about soon. We also have a bunch of experimental APIs, TLS route for like SNI routing, TCP route, UDP route, and then listener set mesh. This one's brand new. We'll talk more about that later. And backend traffic policy. But this was meant to be a really quick overview because most of what we want to talk about is what's here, what's next, that sort of thing. If you have any questions, there's the link to the documentation, but also bring your Q&A at the end here and meet us in the hallway for the hallway track. We'd be happy to answer your questions. Candace?
Hi, everybody. I'm here to talk about what's new in Gateway API as of version 1.4, which was released about a month ago, October 6th. So in 1.4, backend TLS policy and supported features graduated from experimental to standard. Backend TLS policy is an enhancement to the types of TLS termination available for HTTP routes. And supported features provides user-visible information on the features supported by any individual implementation. And that is visible in the gateway class status alongside other information such as conditions. The new experimental features include a mesh resource to hold mesh configuration information, default gateway to provide a better user experience for the transition from ingress to gateway API, HTTP external auth to allow a call out to external service to authenticate, and optionally authorize requests, and additional structure for per port TLS configuration to address a connection coalescing security issue. The QR code that's here is a link to the release 1.4 blog and written by Becca Modebadze, and we'll give you some more information about all of the new features. So I'm going to start with backend TLS policy. It's one of the TLS configuration options available for a connection. Gateway API already had front-end TLS termination via listener configuration, this referred to as edge termination on this diagram. With the addition of backend TLS termination, which is configured using Kubernetes policy, we also get re-encrypt termination, which is both edge and backend TLS termination in succession. So the client must be able to connect securely to the gateway, and the gateway must be able to connect securely with the backend, to give an example of re-encrypt. There are a few use cases. One example, there are a few use cases for backend TLS policy. One example being to provide encryption from the gateway to the application without requiring that the external client have access to the certificates that should be limited to internal entities only. Backend TLS policy has been progressing for about 5 years in different designs. One of the previous designs that led to the choice of policy was called backend properties, and it contained a wide range of configuration options for backends. Can't see the rest of my notes here. But we progressed over time, and right now backend TLS policy is pretty limited to the use case for advising how to connect to a backend pod using TLS, and the backend pod having its own certificate. So here is some YAML giving us some examples of the backend TLS policy and what you can configure within it. So besides providing advice on how the gateway should connect to an application with its own certificate, the other configuration attributes include target refs, so that is up to 16 services, and the distinction between target refs comes from the section names. Same target with different section names is okay. The validation section of the spec holds information about certificates, host name, and subject alternative names. So the host name itself has two purposes. It must be used as the SNI to connect to the back end, and also used for authentication. The host name, which is required, must match the certificate served by the matching back end. However, if subject alternative names are specified, the host name can be used for certificate selection, but must not be used for authentication. If you want to use it for authentication, you have to add it to the subject alt names. It's getting a little bit deep into the details, but so we also have, within subject alt names, we have two types of formatting. You can use the host name, fully qualified DNS name, or you can use URI for incorporating something, for incorporating a URI, for example, to use a SPIFFE ID. Also within the validation, there are two different types of certificates. There are CA certificate refs, and you can use depending on the implementation, it's either a single CA certificate ref or up to 16 CA certificate refs. You have to check with your implementation to see which was chosen for it. And if you instead want to use system certificates, you can use well-known CA certificates instead. And I'll hand it off to Lior.
Hey everyone. Yeah. So I'm going to speak a little bit about supported features. And I'm going to go through this real quick because I want to leave time for questions, and I already talked about it for the last few maintainers tracks. So we wanted to provide discoverability mainly, and what supported feature actually is, which is final GA. It's providing a standard way for us or for a gateway implementation to basically report what features their implementation support. It's also a convenient way for tooling, should you wish to develop them or other tools be developed to actually consume these features. We're going to see how they look like in a minute, but it's basically a machine-readable features. And then warn basically if someone applied something that the implementation may not support. And lastly, it's a strong link between what me as an implementation declare I support versus what the conformance test that the project requires actually tests. And just we're going to look a little bit how it looks like. So we can see, for example, this gateway class, and that's the place where we decided to host the support features for gateway implementation. So within the status, when an implementation actually declared that the gateway class is accepted, meaning it's programmed, so it's going to also publish the supported features it supports. And just as an example, here you can see HP route. This means I support all HP route core features. For those who are not familiar with our conformance levels, we're going to add a link to that later. But then we're going to go and list some extended features, right? Like I support HP route path redirect. And yeah, basically, as someone who is using the gateway class or the gateway implementation, they can just, kubectl get gateway class and understand what do I support and what not. Plus, it is also reflected in our conformance page, so you can just open the Gateway API website and see in a nice table what's being supported. Now I'm going to go through experimental features as well real quick. Candace described it a little bit. We have mesh resource, we have default gateways, we have HP external loss, and we also have a fix. It's called connection coalescing security, which we're also going to touch a little bit. But yeah, starting with the mesh resource, that's a net new thing, an experimental feature. Like we introduced a new resource thanks to Flynn. Not sure if Flynn's here. which basically provides us a way to configure mesh-wide configuration. Whether it's whether it's a good place to host the supported features we discussed previously for mesh implementations, because we also have mesh implementations implements the Gateway API, or whether it's a good place to expand for new configurations. As an example, we also have kind of concrete plan to host some trust bundles and to have the mesh resource hosting configurations to authenticate off cluster gateways, or what we mostly familiar with is like cloud gateways that are not in the cluster, but they need to authenticate to the mesh. So this is something we're kind of planning in short term. The other experimental features, default gateways. A lot of the people, we've been doing service a lot of time. We want to increase adoption for Gateway API. So default gateways kind of aims to simplify the UX, right? As an app developer, I don't necessarily want to know what gateway I need to bind my HTTP route to. I just want to write the route and get everything working. So this is something that's being developed. Two small things to note is that the cluster operators will be the ones in control of what is the default gateway. Plus, we also support multiple default gateways at once to allow migration and basically with zero downtime. Another thing is the external auth. That's being a long requested feature, right? People want to delegate authorization to external servers. So some of the people in the audience probably be familiar with like xauthd or other forms of calling the same feature, but it's basically a way of defining a filter and say, oh, for this specific route, I want to delegate to an external service, whether it's gRPC or HTTP, to basically decide whether the request should be allowed or authorized or not. So that's being introduced as well. And lastly, as I said, this is more of a important security fix. We basically incorporated some logic to disallow TLS settings to be configured on a listener. I'm not going to get too much into it, but basically this removes the risk, it eliminates the risk of reusing misconfigured TLS settings. What's next?
All right, yeah. So what's next? As Shane kind of said in the intro, we're at V1 now. We have been for a little while. We're stable, but there's a lot more that we need to do to get to kind of like table stakes. There's features that we need to make sure that we build to close the gap between what people are doing with Ingress today versus what we want to be able to do with Gateway API to be able to adopt that. So we've got a lot coming. One of the big things is a documentation overhaul. We've kind of grown organically over time, and we know that it's a bit jumbled. So we want to make sure that this is accessible and easier for new contributors to engage with and understand and adopt. We are working on improving guidance for CRD providers, particularly for some of those like managed deployments that provide the CRDs bundles in a managed Kubernetes install, so that you don't have to go through the stumbling block of trying to install the CRDs yourself. But we want to make sure that's a consistent experience across various providers. authz is something I've been working with Lior on. Cores, again, just table stakes, retries. We have them in experimental for HTTP route. We want to make sure we also get that to standard, as well as have parity with gRPC route for timeouts and retries. Listener set is a way to start taking some of that configuration that we do think app developers want to be able to use and move it off of the gateway, and also be able to scale that to more domains and put some of that control back in the hands of the app devs, as well as looking at that potentially to solve some of the issues of being able to have multiple logical gateways within a cluster mapped to like a single underlying load balancer. So for just efficiency and not making sure that you're not using more compute than you actually need to reduce costs. Backend MTLS is the client cert to backend. That's something that we want to just an enhancement to kind of the backend TLS policy. And then front-end MTLS, not just terminating TLS, but also making sure that we're doing client cert validation as kind of an improved security posture there. We have TLS route for SNI routing, where we have work ongoing to move that to standard. I think in the next release is kind of what we're expecting there. And to get all of this to you faster, We are working on more frequent experimental releases. So we're changing up our release model a bit. We'll be tagging monthly experimental releases in addition to the expected regular cadence of our standard channel releases. So the greater Gateway API ecosystem. Gateway API has really been a kind of foundational building block, and particularly within the past 6 months or so, we've seen kind of a proliferation of newer sub-projects and related projects to extend and expand upon the kind of common core that we've built for the past several years. So the Gateway API Inference extension was one of the earliest of those. You'll hear a little bit about that soon. The AI Gateway Working Group is another attempt to kind of focus on some of those AI consumption models and some of the like non-serving use cases. And then the Cube Agentic Networking subproject is the latest initiative there. So the AI Gateway Working Group, we're developing standards for the non-serving side of inference. So while the inference extension is focused on in-cluster model serving, a lot of what we want to do is layers on top of that and around that. This group is heavily involved with SIG Network and multiple sub-projects, all the ones I just mentioned, and also working with SIG multi-cluster, SIG security, working group serving, AI conformance, to make sure that we have a kind of a unified story across this real proliferation of groups to make sure that we're doing this in a kind of logical, joined together way. The current focus of the AI Gateway Working Group is on payload processing and egress. So payload processing is this capability of looking inside the body of requests. This is something that we have considered and talked about in the past for capabilities like firewall, WAF, PII redaction, things like that. But it's also just been kind of AI has kicked it up a notch, and egress is kind of a similar story. We've long had user stories for egress for mesh type use cases of controlling access to off-cluster resources, but now that we need to care about like token management and expenses, API keys, and this use case for these AI services, we want to make sure that this is a capability that we're kind of ratcheting up the urgency of building an implementation for. And slides there, you can see the Working Group AI Gateway repo, and I'll hand it off to Kellen now.
Cool. Thanks, Mike. Thought you were going to get away from AI and inference. You're not. Sorry, guys. I am one of the maintainers of the Gateway API Inference extension, also known as Inference Gateway. So what is that? It's a great question. Well, what it is it's a set of APIs, deployables, and libraries to help transform your gateway into an inference gateway. And as Mike mentioned, that is strictly self-hosted. That's where we focus. We try to make that more efficient. And we do that by describing an inference pool. So an inference pool is conceptually just a set of model servers similar to a deployment that you would have. And then typically with old deployments, you would set a L4 load balancer service in front of it. Well, we found that there's efficiency with treating it more like an L7 where we crack open the body and we take a look and we can use things like KV cache-aware routing and get significantly better performance based off the routing of that body. So we do that by utilizing XProc protocol, which was developed by Envoy, but it's now supported by Nginx and other proxies such as Agent Gateway. So excited to have those people on board, but the way that works is you treat inference pool like a backend ref in your HTTP route. The proxy sees that and will make a call out to the XProc server. We call it the endpoint picker, where you have endpoint selection here, if you can see that on the screen. And then we take a look at the body, we take a look at the state of the model servers, and we'll pick the best endpoint for that. We are also integrating with broader ecosystems. LLMD, if you've heard about that, we work with them a lot. They're helping us bring PD disaggregated serving to Kubernetes, as well as state-of-the-art serving like YDP and mixture of experts. So we have gone GA. It's been pretty quick. As you know, as everyone here knows, AI/ML is quick. So the inference pool API is V1, as well as the base EPP implementation. But we're not done. We're going to continue to experiment. We have, like I mentioned, the interesting things like YDP and MOE. We have multi-cluster inference pool, which is going to be talked about tomorrow, so I won't go into that. We're looking into how we can support RL, and then beyond LLMs. LLMs is the focus right now, but we'd love to support multimodality, diffusion models, things like that. And I will pass it off to Lior.
Thanks, Kellen. Guess what? agentic, another way of saying AI, but a different language. What are we doing? So yes, a lot of users, I'm sure some of you here today are looking into how we are running agents in Kubernetes. And we as a group kind of identify this, and we obviously have the goal to adapt the networking layer to the emerging ecosystem of running agentic AI workloads. I would also be careful and say that some of us are calling agent workloads are the microservices for AI, right? And as we all know, these new creatures are basically requiring AI-first protocols, things like MCP, Model Context Protocol, A2A, agent-to-agent, and things that are emerged, and they are making the networking life very, very, very hard because yes, so we as a group, we are planning to provide consistent and auditable connectivity and provide governance for these workloads, these agent workloads running in Kubernetes to communicate with MCP tools, whether they're running in Kubernetes, whether they're running remotely. We're going to look at it in a minute. But we're trying to not be opinionated on whether it's ingress, whether it's egress. We want to cover a big tent of providing basically the same functionality, the same set of APIs that will cover ingress, egress, east-west traffic to provide agent developers what they need. So this is just like as an overview. This is how we started. What do we think the project could look like? You would see agentic networking specifically. We're not calling it a gateway, or we're not calling it anything specifically because we want to focus on the APIs, want to focus on the capability. But as you can see, these has a lot of arrows, right? Like agents talking to tools, talking to other agents. You would see a small mark next to the LLM. That's a maybe potential future scope that requires a lot of collaboration with AI Gateway, with other groups in the Gateway community. But how do we really start? So the project, we're trying to take this project to start in a case we hear is most common for most of the users, which is, okay, I'm running my agents. My agents running Kubernetes. I want to govern. I want to provide security policies, or I want to provide authorization to tools. And basically, probably some of the people here are asking themselves, okay, how is this different from a regular authorization we're all familiar with, right? The reason it's different, it's because these new protocols, which they encode a lot of the things in the body, things that actually are not available for or proxies basically didn't need to care or didn't need to take care of them before. So we need to kind of look at the body and understand and infer things in a very efficient way. So this is just one of the scopes we're trying to get is the very first milestone. Okay, how do we provide these governance policies from agents to tools, whether remotely or not? And join us, yeah, please do. As I said, we are planning to cover a big tent here. We do need use cases, right? All of us and people here in the audience that are developing Gateway APIs, we think we know what we're doing, but we're definitely not. So we do need feedback, the people that are actually going to use it. And we are planning to iterate fast on it and include, as opposed to Gateway API, which is, it's a set of APIs, and then we bring out vendors to implement these APIs and release it to users. We wanted to do we want to prototype, essentially. We want to prototype, we want to get the feedback and make sure we're getting it right, and not just we're thinking we're getting it right. So and as I said, we're aiming to cover a variety of network implementations, whether it's meshes, whether it's gateways. So yeah, there's a QR code. I hope it's big enough. That gets to the agentic networking repo, where you can find a Slack channel. There is a Zoom meeting that's going to be there by the end of the week. And yeah, that's all on agentic networking stuff.
Yeah, so unfortunately, there's only 5 of us up there, but who makes Gateway API possible? Plenty of people, more than 5 of us for sure. I'm sure a lot of you out here, I know for certain a lot of you out here help make this possible. We have plenty of organizations that contribute experimental APIs, the 2 adjacent sub-projects, mine being one of them, probably the most harebrained of them, which is fine. Also, special shout out to all our maintainers, both current and previous, as well as these sub-projects. Thank you for taking actual responsibilities and dealing with the headache of what is open source. It's fun, but we all know it's a headache at times, which is fine. So thank you. And then one more quick thing. Like Lior said, please join us. We're doing a lot of interesting things. Would love your feedback. Even if it's just, you can make this better. To me, that's everything. So thank you. We're free to take questions.
Yeah, so again, we said at the beginning, have you used Gateway API in anger? Are you confused about it, so forth? We don't actually get, I was gonna put the mic up there. We don't actually get a lot of user feedback, which we would love to think what meant that everything works great, but we know better. So the more feedback you can provide, as critical as it may be, is actually incredibly helpful to us. So please ask it now, catch us in the hallways, put something on a GitHub discussion, an issue. Please communicate with us your problems with Gateway API.
So I'll just step up to the mic. I'm wondering, I see in the Slack channel periodically some really interesting discussions like how does DNS fit into this? How does this fit into this? How does that fit into it? Is there a way that some of those conversations are being kind of tracked as like, oh, this is a key conversation for people to understand if they're wondering about DNS, or oh, this is a key conversation, about this other topic?
Yeah, so I think we have a lot of kind of ad hoc conversations that might come and go, but definitely for the stuff that we care about, we want to have open issues and kind of track those. And we've gone through a few iterations of planning processes, and we're definitely going to continue to iterate on that to make sure that the things that keep coming up as like relevant concerns for many different implementations or many different use cases or end users is the stuff that want to make sure that we're prioritizing. So.
And we do have a closed, we do have the beginning of a gap for DNS management, which we're going to be talking about at one of the special interest group, Birds of Feather, later today or tomorrow.
So I fully intend on using the hallway track a bit later. Oh, can you hear me? Yeah, so I fully intend on using the hallway track a bit later, so don't be surprised when I try to flag you down. So specifically when it comes to the open source implementation and the Kubernetes native implementation on the gateway, like, is there a roadmap or is there something within your guys' purview when it comes to multi-cluster, multi-regional implementations as we begin to go down this track? We've seen a bunch of customers specifically within our purview that are concerned and are trying to get, the 4.9 SLA when it comes to these multi-regional cluster offerings. And, within our current implementation, specifically inside of GKE, the lift to get from a regional cluster to a multi-region cluster has provided some sorts of frictions with some of our customers in the past. So that's GKE specific, but just specifically within the Gateway API, like what is the future of multi-cluster and how what are your timelines with regards to that? What are you tracking?
This has come up a lot over the years, and we've never actually gotten anything really firm on multi-cluster. The most recent thing that's been happening is actually happening in the periphery of Gateway API is getting egress figured out. So the AI Gateway Working Group, the Agentic sub-project now, both need egress, and part of that is for multi-cluster use cases, but that's, I think, different than what you're talking about. You're talking about like multi-cluster ingress from external load balancer, stuff like that.
Yeah, I'm talking with like, running services similar to the way that you'd run your spanner databases, where you'd have like redundancy, access, and those are obviously technical problems, and this is specifically with regards to the gateway itself.
Yeah, so we do have like a preliminary implementation of Gateway API working with MCS API, the Multi-Cluster Services API. That's been something that's been experimental for a while. What's happening most recently is over in the inference extension. They're looking at one of the constraints of the Multi-Cluster Services API is that it's tied to the concept of service. So the inference extension is working on a new inference import model with an annotation to tag it for export to follow like a similar pattern, but kind of longer term there, we're also going to be looking at how do we make the approach this in a more generic way to have potentially like a new construct for exporting resources across clusters and seeing how we might be able to apply that to new resources, whether that's gateways or other such things, kind of as the need arises, rather than have a proliferation of star import new CRDs. So yeah, I'm working with some folks on that and hoping to be able to talk about that 6 months from now in the early stages.
I look forward to the results of the genericism. I think it's going to be a huge benefit to the community. Thank you, guys.
Hi, I'm Joey from AKS. So recently I'm running the Istio ambient end-to-end test. Then can you hear me? Yeah, recently I'm running the Istio ambient end-to-end test. Then apparently it triggered all the gateway confirmation test, which is pretty cool. Then I realized that there are some like exponential features that was running automatically. That's the reason some of my tests keep failing. And I just realized after several iterations, I just wonder whether there are, I guess there must be some easy ways to turn off. Actually, I found out by digging into the code, but I wonder if you could improve the document, or maybe I could create a PR like to improve the document. That will be easier for us to run these confirmation tests. Yeah.
Lior wants it.
So to just make sure I understand the question correctly, are you asking how do you run the conformance test without experimental features?
Yeah.
So yeah, I mean this, it should be documented. Are you running Istio, you said?
Yeah. I'm doing
So yeah,
that.
it should be documented. There is a CLI for running the conformance test if you want to reproduce yourself. Also, Istio repo themselves, they publish the conformance tests. But yeah, it's definitely possible with the current CLI. And if there's no documentation that you can find on this, you can hit me on Slack. I'll help you.
Actually, I figured out eventually, just not that straightforward. I mean, if it can be
Okay, yeah, so
documented,
basically you're saying improve documentation.
Yes,
Okay.
yes, exactly. Cool.
All right.
Yeah.
Unfortunately, we are getting asked to go, so please do catch us. We'll be out there in the hallway in a second, but we need to get off stage. Thank you, everybody.